everyone, this is Himabindu from the Department of CSIT. So today in this video, we would like to explain about the pushdown automata construction. So how to construct a pushdown automata and for the given languages. So here in the previous videos, we already discussed about the terminologies of pushdown automata and how to represent a pushdown automata in the graphical representation and transition function of pushdown automata. And here and also discussed about the acceptability. So what type of acceptabilities we have for the pushdown automata? One is the final state acceptability and second one is the empty stack acceptability. So here in this video, how to construct a pushdown automata, we will discuss with the example. So here the constructing a PDA that accepts language 0 power n and 1 power n. So for the n greater than or equal to 0. And here when coming to the 0 power n and 1 power n. So for this kind of languages, how to construct a pushdown automata in the sense, we have to first take the language elaboration. So in that one, 0 power n and 1 power n. So it should be 0 or 0 greater than or equal to n. So here if you take 0, n is equal to 2, 3, 4 and so on, 0 up to 1, 0 power n. So 0 power n is equal to 1. If you take n is equal to 1, we will write 0 power n and 1 power n. It is a string of 0, 1. And if you take n is equal to 2, so 0 power 2 is nothing but 0, 0, 1 power 2, 1, 1. And if you take n is equal to 3, 0, 0 and 1, 1 and so on. So this is the language. So this is the language. For this kind of language, we have to construct a pushdown automata. So here in the finite automata, we discussed how to construct a finite automata. So with the minimum string, whatever there, but that string first we have to construct. Like that here also, we have to construct a pushdown automata. And here the input additionally for the finite automata, the stack is included here. And we already discussed about the definition of pushdown automata. So let me write the definition of pushdown automata. So in that one, so language of PDA. So in that one, so first one is about the queue. So queue is nothing but how many states required. So here the minimum length is 0, 1. So how many states we require? We require minimum length plus 1 is equal to 3. So 3 states are required. Let me write Q0, Q1 and Q2. So these are the queue. This is nothing but queue. And next one for in 7 tuple notation. So tau symbol, so top of the stack symbols and final state. So here the Q2 is the final state and Q0 is the initial state and next 1, 2, 3, 4 and the remaining 3. So transition functions we have to write and next Z0 is the initial stack symbol and next epsilon. So epsilon is nothing but, so it is a combination of zeros and ones. So epsilon is equal to 0, 1. So this is about the definition. So first transition function we will construct. Later we will draw the transition diagram. So here the language says that 0 power n and 1 power n. So if you take the top stack symbols, so initially we have to push the Z0 and here after reading this kind of string 0, so 0 if the string which is having the 0 input symbol, we have to push 0 and whenever we have to empty the stack and after consuming all the if you take the final state acceptability, so in that one, so the stack should be reaching the Z0. So whatever we have in the initial state, after reading all the input string, again we have to reach for the initial stack symbol only. So if you observe the 0, if you insert, how many zeros are there? We have to insert the zeros. and whenever 1 appears, we have to pop the 0. Pop 0. So then only the 0 is popped and again it reaching the Z0 and the string is acceptability in the state. So the final state acceptability is done here. So here the language says that 0 power n and 1 power n. So it is the 0 is followed by 1. So n number of zeros followed by n number of 1. So how many zeros we are pushing and how many ones are appears, we have to pop the zeros. So that is the condition we have to follow for the pushdown automata. For this condition, how to construct a pushdown automata. So let me write the transition function. So transition of, so here the Q0 is the initial state. So here initial state is Q0 and A is the 0 is the pushdown automata. A is the input stack symbols and Z0 is the top of the stack symbols. So this already discussed in the previous videos. So what is this? Three things are nothing but ID representation, instantaneous description. So this is the current state, Z0 is the current state. Current state, this is the next input symbols, and this one Z0 is the top of the stack symbol, So we already discussed this. So here, whenever if you take this string, we have to take one input string. We will take this string as a W. So W is equal to 0011. So for this string, we have to construct a pushdown automata and we have to construct a transition function for this one. So here the first 0 we are taking. So for this 0, from this Q0, if you take 0 as an input, so the top of the stack symbol is Z0. So here what we have discussed, so 0, whenever 0 appears in the string, we have to push that into a stack. So here, so same state we have to there and 0, Z0 we have to push. And what is this contains? The Y value after replacement of this top of the stack symbol, 0 is pushed into the stack. So that's why 0 is included with the initial stack symbol. And next, so again 0 is there and whenever 0 appears and top of the stack symbol is here, top of the stack symbol after, yes, let me write. So initially first we have Z0 and after reading the 0 as an input, we have 0 also. And again, if again 0 is there and top of the stack symbol already 0 and again 1 0 is inserted. So that is the thing we are writing here. So in which state it is? The same state we have to there. So Q0, 0, 0. I am writing the only top of the two symbols. And next transition of Q0. And here we already finished the two input strings and here whenever 1 appears, so 1 appears, so Z0 and 0 and we have to pop 0. So whenever 1 appears, we have to pop the 0, top of the stack symbol. So 1 appears, top of the stack symbol is 0 and it should be Q1. We are changing the state for the next input symbol and top of the stack symbol is Z0, Z0. So why? Because already 0 popped. So remaining thing is 0, Z0 only. And next Q1, 1 appears again. So 1 appears, Z0, 0. So this is going to be popped. So again 1 appears. So here the top of the stack symbol is 0 and Q1 Z0. So 0 already popped. So remaining thing is only Z0 is there. And here again, so whenever this kind of situation occurs, so from the Q1 state, the only empty stack is the stack initial stack symbol is represented, that should reach the final state. So here the Q1 comma empty string. So after reading or consuming all the input symbol, only empty string is there, and top of the stack symbol is Z0, and it is reaching the Q2 epsilon. So this is the final state. So it is reaching the, after reading all the input string, it is reaching the Q2. So here this thing we have to represent in the transition diagrammatic representation. So here, so initially top of the stack symbol is, initially the state is Q0, and for this one Q0, 0 as an input symbol. So 0 as an input symbol. So here the top of the stack symbol is Z0. Top of the stack symbol is Z0. So it is reaching the, it is pushing the 0 into the stack. And again 0 as an input symbol, on top of the stack symbol is 0, and here 0 is included into this stack. So here these are the two things. And next, whenever 1 appears from the Q0 state and 0 is the top of the stack symbol, and what we have to do, we have to pop the 0. So here the 0, 0 Z0 and 1 0 Z0. And here which state is reaching? Q1. So, and here also, so whenever this kind of situation, so here empty string, so here empty string is there, and it is having the top of the stack symbol is Z0, and it should reach the final state. So this is the final state Q2. So this is about the transition diagram. So transition diagram for the language 0 power n and 1 power n. So this is how we have to construct a pushdown automata for the given language 0 power n and 1 power n. And next example, so here we are taking the WW reverse. So here W and W reverse, which is the alphabet which is having 0, 1 as an alphabets. So in that case, the W is in, the condition is the W is in 0 plus 1. So either it starts or ends with 0 or 1. So at that too, it is a transition star symbol. So it includes the epsilon, it includes the sigma star. So sigma star is nothing but it is also included, empty string also included into the star. So for this one, we have to write, first step what we have to do, we have to construct, we have to elaborate the language. And here the WW reverse. So here, what are the combinations of the strings for the given languages? WW reverse. So if you take either it starts with 0, so here this is the starts with 0, and if you take 1, next one 1, and the what is this string? This is the W. If it is a W, what is the reverse of this W in the sense? 1 0. And next one more case, 1 0 0 1, and so on. So this is the word and this is the W reverse word. So this is how the strings formed with the combinations of 0, 1. And here for this one we have to construct a pushdown automata. For this kind of things we have to write the language first, PDA, which is having the 7 tuple notation. In that one the Q, and so here the minimum Q, sigma. So sigma is equal to 0, 1. And next, so stack symbols. So what are the stack symbols? Are nothing but here 0, 1 and Z0 also included. So Z0 is equal to initial stack symbols. And next, Q0 is the initial state and F is the final state. And next, top of the stack symbols, transition, function, and these are all. So these are all the definition of pushdown automata. So here we already discussed about this definition. So in that one we have to first step what we have to do in the sense we have to insert the Z0 into a stack, and for this kind of languages what type of push and pop operations we have to do. So here we have earlier we have 0 is followed by 1. So here there is a no particular condition kind of thing. Either it starts with 0 or ends with starts with 1. So here it starts with 0. In that case, how to do the push and pop operations. And in case of 1 is start there. And for every case, we have to write the push and pop operations in the transition function. So here, so if it is a top of the stack symbol, so initial state is of the PDA is Z0. So Z0 we have to take, and Q0 is the initial state. And here the first symbols we have to push onto the stack. So first symbols we have to push onto the stack is either 0 or 1. So we have to take 0 first, and top of the stack symbol is Z0. So here the Z0, Q0 to Q0. So this already discussed. So 0 is the input stack symbol, and Z0 is the top of the stack symbol, and Q0 is the next state, and we are pushing the into the 0 into the stack. So we finish the 0, and what about 1? So for in case of the string starts with 1 or 0, so we finished when the string starts with 0, and we have to write for when the string starts with 1. So this is like when the string starts with 0 1 1 0. So this is the string for the 0 is starting, and for this kind of string, so this is the string which starts with 1. So we have to construct both this kind of languages, both this kind of strings. So here 0 is all 0 is the 0 is one situation and 1 is the one situation. And for 1 we have to take the 1 as an input symbol, and Z0 is the top of the stack symbol. So 1 is also going to be pushed. And grow the stack by pushing the new symbols on the top of the old W part. So here, so like that, in case of any input symbols are there, so here 0 is there, 0, 1. So how many word we have to divide this one? How many are there in this W part? We have to take the input symbols and we have to push that into a stack. How to push that in the sense? Here 0 is there. Already 0 top of the stack symbol is there. 0 we have to push. And one more case. In case of 0 is there and top of the stack symbol is 1. Again we have to push that into a stack with the 0, 1. And one more case, so we top of the stack symbol is different here and the input string is same. And same thing for 0 finished, and next to 1 we have to take, and for the two conditions, the top of the stack symbol is either 0 or 1. So 1 is a input string and top of the stack symbol is 0, and we have to push whatever there in the string, either it is 0 or 1, we have to push that into a stack. And for the 1, we have to take 1 as an input and top of the stack symbol is 1. We have to push that 1 into a stack. And we have to divide this. So we have to divide this W and W reverse. Then only we will construct a pushdown automata. How to divide this and what type of separation we have to do. And we have to perform a reverse kind of push and pop operations. So here the switch to pop mode non-deterministically. So here we have to switch to a pop. Till now we have pushed the stack symbol. So here we are pushing the input symbol into a tag, but now we have to switch to pop mode. So here whenever the string empty, so in between if it is an empty string, so on top of the stack symbol is 0 and we have to move to one more state, another state. So till now in the same state we have. So how many input symbols are there? We have to left in the same state, and here we just moved from pop to push to pop operation. So moving from pop operation in the sense, so here whenever empty symbol is appeared, and top of the stack symbol is 0 or 1, whatever it is, we have to move to the next state. So this is 1. So this is the top of the stack symbol is 0, and here 1. So same we have to pop operation. And even also for the Z0. So initially what we inserted into the stack, whenever we reach that kind of thing also, we have to move to the next state. So observe this, Q0 is the current state and the Q1 is the next state. In these two conditions, we are in the same state only. And here we just changed the operation and we move to the state Q01 to Q0 to Q1. And string the stack by popping matching symbols. So matching symbols, we have to pop the symbols. So W reverse is the W reverse part. So here in between we have, if you take input symbol, empty symbol, and this is the reverse. So here for matching symbols we have to pop, and here how to pop? 0. So 0 as an input symbol, 0 is the top of the stack symbol, we have to pop. And 1 as a, so when same kind of input symbol, so top of the stack symbol is 1 and the input symbol is 1, we have to pop. And top of the stack symbol and input symbol is 0, we have to pop the stack. And we have to left in the same state. So that is the Q1 state. And here enter acceptance state. So finally in the Q1 state, empty string is empty symbol is appeared and top of the stack symbol is Z0. We have to move to the Q2. That is nothing but final state. So this is the thing what we constructed for the given language of WW reverse, the language which contains WW reverse. So transition functions, whatever we have written in this transition function, we are diagrammatically represented here. So initially we pushed Z0 into the stack. So here, well, let me write Z0 into the stack. And if you take W is equal to 0, 1, 1, 0. So for this kind of string, how we have to working this PDA. And here if we are initially we are pushing 0, Z0, and first string is 0. So here the 0 is there and we have to take this 0 is there and top of the stack symbol is Z0. And what we have to do, we have to push the 0 into the stack. And next, string contains 1. So here again we are in the same state. After pushing 0 into the stack also we are in the same state. So here the one input string is there. So here one input string and top of the stack symbol is 0. So the 0. And what we have to do, we have to push that 1 into the stack. And next we are in the same state. So next string is we have to divide this and empty appears. So empty string appears from the Q0. So empty string appears Q0. 1 is the top of the stack symbol. So top of the stack symbol is 1. So here what we have to do, we have to remain in the same state. So this is done. And next it is reaching the Q1. So in the Q1 state, 1 appears, on top of the stack symbol is 1. We have to do the pop operation. So this 1 is popped from the stack. And next, after we are in the same state, this is nothing but how many 1s are there. We have to pop all the 1s. And next, from the Q1 state, 0 and 0 for this also. These two operations are done. And next one, we are in the same state. 0 as an input symbol and 0 is the top of the stack symbol. and we have to pop the 0 also. And here what is the left thing? Z0. So in the Q1 state, Z empty string, so all consumed. So for all the string is going to be consumed, and this epsilon is there. So in that case, epsilon input string, and top of the stack symbol is Z0, and we have to push a empty string also. So that is nothing but Z0 only. And this is reaching the final state Q2. So this is how it is reaching the final state. So this string kind of things is accepted by this pushdown automata. So this pushdown automata is accepting this string. So this is how we are constructing a pushdown automata. This is a grow stack, and switching to pop mode, and pop stack for matching symbols, and go to acceptance. So this previous transition diagram which we represented in the transition diagram. So these are the references. So this is about the constructing a pushdown automata. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.